We are back, continuing with the same lesson on transportation problem. Our next topic is Vogel approximation method. We are done with the northwest corner method and least cost entry method. Now, what do you mean by Vogel? Under this method, we determine the penalties which will help in allocation of the best cost. Initial feasible solution you get is the next to the optimal solution. So when you're using Vogel, the amount that you get is next to the optimal solution. Steps to be followed in the preparation of Vogel approximation method. 1. Determine the two smallest costs in each column and rows and find the difference. Now the difference is what we call penalties. So you say the highest minus the lowest. 2. Select the row or column having the lowest penalty and allocate maximum possible amount to the cell with the lowest cost in either row or column. 3. Cross the row or column whose total has been exhausted. 4. Construct the reduced matrix with the remaining row and column. Then 5. Repeat step 1 to 4 until all rows and column total are exhausted. So these are the procedures or steps to be followed when you are using Vogel approximation method. Now we move to the problem. We are still using the same problem which was under northwest corner method. Now under this method, we need to get the solution, which was the solution already after doing the formulation. So this is the question. This is the nature of the question that you will find. Now we have this question. Our next step is now to do the preparation of the account. Now how can we prepare the account? So number 1, we prepare the matrix. So we are preparing the matrix. So we have 6, 4, 1, 3, 8, 7, 4, 4, 2. Now this is Voi, Chemelil, Nairobi. Then we have Kapsabet, Busia, and Meru. Now our demand, as far as our question is concerned, is 20.95, and for Nairobi is 35. For Kapsabet, supply is 50, then 40 for Busia, and 60 for Meru. Now we said to actually find out if the question is balanced, you total both sides. You realize the total gives us 150. So the question is balanced. Now number 1, procedure number 1. We are identifying the amounts which are lowest in cost. So the lowest cost in our matrix is 4 and 1. So we say 4 minus 1. Now let me bring our penalty here. So the penalty will be 4 minus 1, 3. The lowest cost in our next row is 3 and 7. 7 minus 3, 4. The lowest cost in Meru is 4 and 2. 4 minus 2, 2. Now we come to the columns. So we are done with the rows. Come to the column. Identify the lowest two costs. We have between 6, 3 and 4, we have 3 and 4. 4 minus 3. So our penalty here is 1. Then 4 and 4 are the lowest. 4 minus 4 is 0. 1, 7, 2, 2 and 1 are the lowest. So you get 2 minus 1, we get 1. So this is our first penalty. So in our first penalty, we have 1, 0, 1. In our row, we have 3, 4, 2. We said pick the maximum. So our maximum penalty is 4. So we are actually taking 4 And in the row of 4, take the lowest cost. Between 3, 8, and 7, our lowest cost is 3. So we start our allocation from here. So can we do our allocation? So 20 and 40. Which one is the minimum cost? 20. So we are exhausting 20, meaning that this row, this column has been exhausted. So we are only remaining with this matrix. This is the matrix which is actually remaining. So in this matrix, we can decide to again come up with the next matrix, or we continue, we create another penalty. So 418742. Our next penalty, 4 and 1, we have only two. We have 3 rows and 2 columns. So we start with rows. 4 and 1, we have 4. 4 minus 1, 3. 8 and 7, we have 1. 2 and 4, we have 2. Now the penalty for this side is 4, 8, and 4. So in the first one, we are done. So the next one is 0 again. 1, 7, and 2. 2 minus 1 is 1. So these are our penalties for the next row. Again, in the next row, pick the highest. Between 0, 1, 3, 1, 2, the highest is 3. So from 3, we do our allocation. Pick the least amount, the least cost in the cells. So our least cost is 1. So being 1, we do our allocation. So meaning it was what is between 50 and 95. No, not 50. 50 and 35. 35 is the least. So we do allocation of 35. 35 has been exhausted. 35, 50 minus 35, you remain with 20 or 15. So meaning that in our valuation, we are done with this column. This column has been exhausted. So we are left with only one row, one column, which is Chemelil. Now in our Chemelil, we'll not go further finding the penalties. So we'll do just direct allocation. So we have 15, allocate here 15. We have 4. No, we have here we said 40 minus 20, so we will remain with 20. So we have only 20 for 8. And then for 6, only here we are left with 60. So once we are done with that, then our next initiative is to determine. We are determining the cells which are occupied. So the cells which are occupied from our equation, we have C, C13. Another cell which is occupied is C. It is C12, and then C13, C12, C13. Then the next one is C21, and then C22, which is this, and then C31. No, C32. So these are the cells which are occupied. So we take the values as we get the product of the values. So C11 is 15 times 4, which is giving us 60. C13, 35 times 1, which is 35. C21, 20 times 3, which is 60. C22, C22 is 20 times 8, which is 160. And then C 3, 2 is 60 times 4, which is giving us 240. Now, when you total this, you will get 555. Now, this is our maximum cost. This is the minimum cost of transporting goods from source to the destination. Now, this one, we can clarify this. So to know whether the problem is balanced, we've done that. Now, this is the solution. So in our solution, you realize that these are penalties. We got the penalties. We have given the penalties. 1, 2. So the maximum penalty is 4, which is here. We are done with that. So we have the solution here. This is the solution. So the solution, cell 1 is 15 times 4, 60. Cell 3, 3 times 1, which is 35. Cell 2, 1, 20 times 3, 60. Cell 2, 2, 20 times 8, 160. Cell 32, 60 times 4, 240. Total, 550. So the best initial visible solution for shipping the product from source to the destination is shillings 555. 11,